So today we have to study the structure of atom, part 5. So in this part we have to study particle nature of electromagnetic radiation, Planck's quantum theory, and black body radiation. Okay, so particle nature of electromagnetic radiation. So what is particle nature of electromagnetic radiation, and Planck's quantum theory, and then black body radiation, right? So particle nature of electromagnetic radiation. First, we will go for the Planck's quantum theory. So, what is Planck's quantum theory? What is the postulates of this theory, right? So, before going to that theory, so why this theory has explained, right? Because there are certain experimental fact or else properties of some of the black body radiation or else photoelectric effect. So these are the practical impact. So when you do it and then you are getting that effect. Okay, so all this effect doesn't explain by the wave theory. So or else electromagnetic wave nature, whatever we have told earlier classes, that is through the classical physics. So that is not explained by wave theory, right? So what are these? The first thing is the nature of emission of radiation from hot bodies, that is black body radiation, and the ejection of electrons so from the metal surface when radiation strikes. So that is we are calling photoelectric effect, and variation of the heat capacity of solid as a function of temperature, and the line spectra of atoms with a special reference to the hydrogen atom. Now, what is black body radiation? So, before going to that, what is black body? So, then we can say what is the black body radiation, right? The phenomenon of black body radiation was given by Max Planck. So, in 1900. So, this phenomena is given below. The ideal body which emits and absorbs all frequencies is called as black body, right? So what is black body? So black body is nothing but it is an ideal body. So it is not real, it is an ideal body which emits, which release and absorbs all type of frequency. ಸೊ ಯಾವುದೇ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರ್ಬೋದು ಅದನ್ನ ಏನು ಮಾಡುತ್ತೆ, ಎಮಿಷನ್ ಮಾಡುತ್ತೆ, ಅದೇ ರೀತಿಯಲ್ಲಿ ಅಬ್ಸಾರ್ಬ್ ಮಾಡುತ್ತೆ. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಬಾಡಿ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ. And whatever the radiation they are emitting or else whatever the radiation they are absorbing, and that radiation we are calling black body radiation. Okay, the ideal body which emits and absorbs all frequencies called black body, and the radiation emitted by such bodies is called as the black body radiation, right? Now, at a given temperature, intensity of radiation emitted increases with the decrease in wavelength, which reaches maximum value given wavelength, and then start to decrease with a further decrease in the wavelength. Okay, so this is an practically noted things, right? So now whatever the metal, if you take it and heat it at a particular temperature, ಅವಾಗ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, ಸೊ ಇಲ್ಲಿ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ವೇವ್ ಲೆಂತ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ವೈ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಸೊ ಇಂಟೆನ್ಸಿಟಿಯನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ನಾವು ಯು ಕ್ಯಾನ್ ಒಬ್ಸರ್ವ್ ಕ್ಲಿಯರ್ಲಿ. ಸೊ ವೆನ್ ಯು ಡಿಕ್ರೀಸ್ ದಿ ವೇವ್ ಲೆಂತ್, ಸೊ ವೆನ್ ಯು ಡಿಕ್ರೀಸ್ ದಿ ವೇವ್ ಲೆಂತ್, ಸೊ ರೆಡ್ ಲೈನ್ ಅಟ್ ಟಿ ಟು ಟೆಂಪರೇಚರ್, ಸೊ ಅದೇನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, ಸೊ ವೆನ್ ಯು ಡಿಕ್ರೀಸ್ ದಿ ವೇವ್ ಲೆಂತ್ ದ ಇಂಟೆನ್ಸಿಟಿ ವಿಲ್ ಇನ್ಕ್ರೀಸ್. ಇಂಟೆನ್ಸಿಟಿ ಅನ್ನುವಂಥದ್ದು ಏನಾಗ್ತಾ ಇದೆ ಇವಾಗ, ಸೊ ಇಂಟೆನ್ಸಿಟಿ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ, ಸೊ ವೇವ್ ಲೆಂತ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತಾ ಇದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. So that intensity value reaches at a particular maximum for particular wavelength. So ಯಾವುದೋ ಒಂದು ವೇವ್ ಲೆಂತ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಂಟೆನ್ಸಿಟಿ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್, right? So after decreasing the wavelength, the intensity of the radiation what decreases. So intensity ಏನಾಗುತ್ತೆ, ಅದು decrease ಆಗ್ತಾ ಇದೆ. So this is one of the actual fact which doesn't explain through the classical physics, or else you can say that is electromagnetic wave theory, right? So ಇದನ್ನ ಏನ್ ಮಾಡಲ್ಲ, so this thing is not explained. The above experimental result cannot be explained satisfactorily, so on the basis of the wave theory of light. So hence later what happens, Planck suggested that atoms and molecules could emit or absorb energy only in a discrete quantities, and it is not in continuous manner, right? The Planck gave the name quantum to the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation, right? So now what happens in some of the molecules or some of the atoms, they can release energy, right? They can release energy or they can absorb energy, right? And they can release or else absorb energy, it is not in the form of continuous, right? So they are release energy in the form of a discrete amount of energy. ಚಿಕ್ಕ ಚಿಕ್ಕ ಪಾರ್ಟಿಕಲ್ ಆಗಿ ಏನ್ ಮಾಡುತ್ತೆ, ಅವು ಎನರ್ಜಿನ ಕೊಡ್ತವೆ. ಅಂಡ್ ದ್ಯಾಟ್ ಪಾರ್ಟಿಕಲ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್, ಆರ್ ಎಲ್ಸ್ ಸ್ಮಾಲ್ ಪ್ಯಾಕೆಟ್ ಆಫ್ ಎನರ್ಜಿ, ಅಂಡ್ ದ್ಯಾಟ್ ಪ್ಯಾಕೆಟ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಕ್ವಾಂಟಾ, right? Quanta ಅಂತ ಹೇಳ್ತೀವಿ, right? Planck gave the name quanta for such smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. So now, regarding wave, we know that wavelength, we know that frequency, we know that. But now, what about the energy? So energy relation for that waves, how you can give it, right? So hence, according to quantum theory or quanta, according to Max Planck, right? So energy of bundle of packets, small, discrete. He told that, right? So now, what is the relation between that energy? The energy E of quantum radiation is proportional to its frequency, right? And it is expressed in terms of what E is equal to h nu ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದ್ರೆ ಎನರ್ಜಿ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ವಾಟ್ ನ್ಯೂ. ಸೊ ನ್ಯೂ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಸೊ ರೇಡಿಯೇಷನ್ ಅನ್ನ ತಗೊಂಡಿದ್ರೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಅದನ್ನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ. ಹಾಗಾದ್ರೆ ದ ಕ್ವಾಂಟಾ ಎನರ್ಜಿ ಏನಿದೆ, ಸೊ ದಟ್ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ವಾಟ್, ದ ರೇಡಿಯೇಷನ್. ಸೊ ರೇಡಿಯೇಷನ್ ವೇವಿನ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಏನಾಗುತ್ತೆ, ದರ್ ಇಸ್ ರಿಲೇಷನ್. ಅದರಿಂದ ಇ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಚ್ ನ್ಯೂ ಅಂತ ಹೇಳ್ಬೋದು, ವೇರ್ ಎಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್, ಸೊ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, constant h is known as Planck's constant and has the value 6.626 into 10 to the power of minus 34 joule second. So with this theory, Planck was able to explain the distribution of intensity in the radiation from black body as a function of frequency or wavelength at a different temperature. So ಅದರಿಂದ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, ಸೊ ವಿತ್ ದಿಸ್ ಥಿಯರಿ ಪ್ಲಾಂಕ್ಸ್ ವಾಸ್ ಏಬಲ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ದ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂಡ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ರೇಡಿಯೇಷನ್ ಫ್ರಮ್ ದಿ ಬ್ಲಾಕ್ ಬಾಡಿ, ಸೊ ದಟ್ ಈಸ್ ರಿಲೇಟೆಡ್ ವಿತ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆರ್ ವೇವ್ ಲೆಂತ್ ಅಟ್ ಡಿಫರೆಂಟ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಹೇಳ್ತಾನೆ, ರೈಟ್? Now, so this is an experimental setup. So you have glass tube and the vacuum chamber you have, right? And the detector you have, metal surface is there. Detector to metal surface, there is a loop. Okay, there is a connection with the emitter and the battery, you can observe, right? So when you switch on the battery, so battery and a switch on ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, there is no deflection in emitter, so you're not able to get any reflection, right? So now what we have to do, so for a metal surface we have to strike the radiation. ಒಂದು ರೇಡಿಯೇಷನ್ ಏನು ಮಾಡ್ಬೇಕು, ನಾವು ಅದನ್ನ ಸ್ಟ್ರೈಕ್ ಮಾಡ್ತೀವಿ. ಸೊ ಯಾವ್ದ್ರ ಮೇಲೆ, ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ. ಸೊ ಆವಾಗ ಏನಾಗುತ್ತೆ, ಅಮೀಟರ್ ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ಎನ್ನುವಂಥದ್ದು ಕಾಣಬಹುದು, ರೈಟ್? ಸೊ ವಿ ಕ್ಯಾನ್ ಸಿ ದ ಡಿಫ್ಲೆಕ್ಷನ್ ಓವರ್ ದಿ ಅಮೀಟರ್, right? So now, so when it is striking of light beam and the ejection of electrons from the metal surface, so what happens, so when the radiation falls or else strike over the surface of the metal, so immediately what happens, there is an ejection of electron. So metal atom you have, from the metal atom what happens, the electrons are coming out. ಸೊ ಕಮಿಂಗ್ ಔಟ್ ಥ್ರೂ ದಿ ಇಂಟರಾಕ್ಷನ್ ವಿತ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಜೊತೆಗೆ ಇಂಟರಾಕ್ಷನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಇಲೆಕ್ಟ್ರಾನ್ ಎನ್ನುವಂಥದ್ದು ಏನಾಗುತ್ತೆ, ಸೊ ಆ ಇಂಟರಾಕ್ಷನ್ ಅನ್ನ ಕಳ್ಕೊಂಡು ಏನಾಗುತ್ತೆ, ಸೊ ದೇ ಆರ್ ಕಮಿಂಗ್ ಔಟ್ ಫ್ರಮ್ ದಿ ಆಟಮ್. ದಟ್ ಈಸ್ ದ ಇಫೆಕ್ಟ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್. The number of electron ejected is proportional to the intensity or the brightness of the light, right? So that's why what happens, already we know that E is equal to h nu. So ಅದರಿಂದ ಏನಾಗುತ್ತೆ, ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿಯನ್ನು ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎನ್ನುವಂಥದ್ದು ಬರುತ್ತೆ, right? But for each metal there is a characteristic minimum frequency, so that is mu naught ಅಂತ ಹೇಳ್ತೀವಿ, and is also known as threshold frequency. Very very important, threshold frequency below which photoelectric effect does not observe, right? Not observed. For each metal there is a characteristic minimum frequency. So ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಅನ್ನು ತಗೊಳ್ತೀವಿ ಅಥವಾ ಸೋಡಿಯಂ ಅನ್ನು ತಗೊಳ್ಳಿ, ರೇಡಿಯೇಷನ್ ಅನ್ನು ಹಾಕಿ, ಸೊ ಎಲ್ಲಾ ರೇಡಿಯೇಷನ್ ನಲ್ಲಿ ಏನಾಗಲ್ಲ, ಇಲೆಕ್ಟ್ರಾನ್ ಬರಲ್ಲ. ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಡಿಯೇಷನ್ ಬಿದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಎನರ್ಜಿ ಅನ್ನುವಂಥದ್ದು ಹಿಟ್ ಆಗಿ, ಅಂಡ್ ಫ್ರಮ್ that what happens, electrons ejected out. At a frequency mu is greater than mu naught, the ejected electrons come out with a certain kinetic energy. The kinetic energy of these electrons increases with the increase of the frequency of the light used, right? So now mu is greater than mu naught. ಸೊ ಆ ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಏನಾಗಿರಬೇಕು, ನಿಮ್ಮ ರೇಡಿಯೇಷನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರಬೇಕು. ಯಾಕೆ? ಸೊ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಇರಬೇಕು. ಯಾಕೆ? ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ಹೋಲ್ಡ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ವಾಟ್ ಎವರ್ ದ ಆಟಮ್, ಇಫ್ ಯು ಟೇಕ್ ಇಟ್, ನ್ಯೂಕ್ಲಿಯಸ್ ಹೋಲ್ಡ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್, right? Right. So it is because of what? Effective nuclear charge. Effective nuclear charge of what? Nucleus hold the electron. So that is the energy, right? So ಆ ಎನರ್ಜಿನ ಏನ್ ಮಾಡಬೇಕು? So we have to break it. So break ಮಾಡಬೇಕಿದ್ರೆ, so mu naught is the frequency. So that energy is equal to this energy, right? ಅವಾಗ ಏನಾಗುತ್ತೆ, mu naught ಫಾಲ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇಲೆಕ್ಟ್ರಾನ್ ಮತ್ತೆ ನ್ಯೂಕ್ಲಿಯಸ್ ನಡುವೆ ಬ್ರೇಕಪ್ ಆಗುತ್ತೆ, ರೈಟ್? ಆವಾಗ ಇಲೆಕ್ಟ್ರಾನ್ ಏನಾಗಬೇಕು, ಆಟಮ್ ಇಂದ ಹೊರಗಡೆ ಬರಬೇಕು. ಸೊ ಆವಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಮೋರ್. At a frequency mu is greater than mu naught, the ejected electrons come out with a certain kinetic energy. The kinetic energy of these electrons increases with the increase of the frequency of the light used, right? So now mu is greater than mu naught. ಸೊ ಆ ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಏನಾಗಿರಬೇಕು, ನಿಮ್ಮ ರೇಡಿಯೇಷನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರಬೇಕು. ಯಾಕೆ? ಸೊ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಇರಬೇಕು. ಯಾಕೆ? ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ಹೋಲ್ಡ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ವಾಟ್ ಎವರ್ ದ ಆಟಮ್, ಇಫ್ ಯು ಟೇಕ್ ಇಟ್, ನ್ಯೂಕ್ಲಿಯಸ್ ಹೋಲ್ಡ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್, right? Right. So it is because of what? Effective nuclear charge. Effective nuclear charge of what? Nucleus hold the electron. So that is the energy, right? So ಆ ಎನರ್ಜಿನ ಏನ್ ಮಾಡಬೇಕು? So we have to break it. So break ಮಾಡಬೇಕಿದ್ರೆ, so mu naught is the frequency. So that energy is equal to this energy, right? ಅವಾಗ ಏನಾಗುತ್ತೆ, mu naught ಫಾಲ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇಲೆಕ್ಟ್ರಾನ್ ಮತ್ತೆ ನ್ಯೂಕ್ಲಿಯಸ್ ನಡುವೆ ಬ್ರೇಕಪ್ ಆಗುತ್ತೆ, ರೈಟ್? ಆವಾಗ ಇಲೆಕ್ಟ್ರಾನ್ ಏನಾಗಬೇಕು, ಆಟಮ್ ಇಂದ ಹೊರಗಡೆ ಬರಬೇಕು. ಸೊ ಆವಾಗ ಏನಾಗುತ್ತೆ, it requires more energy which is greater than the mu naught. So if you supply greater energy, so then what happens, the interaction, or else whatever the relationship between the nucleus and the electron, so that is broken. And after whatever the more energy you are supplying, so that is converted into what? Kinetic energy, or the movement of electrons, fast movement of electrons, that is through the kinetic energy agi convert agutte, right? So next, Einstein in 1905 so was able to explain the photoelectric effect using the Planck's quantum theory of electromagnetic radiation as the starting point. So next ಏನಾಗುತ್ತೆ, photoelectric effect is given by the Einstein, right? So that is possessed by the photon. So greater will be the transfer of energy of an electron, and greater the kinetic energy of the ejected electron. So ಅದರಿಂದ ಏನಾಗುತ್ತೆ, the frequency. So frequency is nothing but what? So now we have to explain that terms, magnetic wave or else electromagnetic radiation wave theory is now converted into what? Particle nature. So ಏನಾಗಿದೆ, ಅದು ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ. ಸೊ ಈಚ್ ಪಾರ್ಟಿಕಲ್ ಪೊಸೆಸಸ್ ಎನರ್ಜಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? ಎಚ್ ನ್ಯೂ. ನಾವು so we are relating what? Particle and the wave. So E is the energy of particle which is related to the what? Frequency of that particular radiation, right? So ಆ frequency ಎನರ್ಜಿ ಉಳ್ಳ ರೇಡಿಯೇಷನ್ ಬಿದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಎನ್ನುವಂಥದ್ದು ಇಜೆಕ್ಟ್ ಆಗುತ್ತೆ. ಇನ್ ಅನದರ್ ವರ್ಡ್ಸ್, ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಇಜೆಕ್ಟೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದಿ frequency of the electromagnetic radiation. So this is the clear picture you are getting. E is equal to h nu. E is the energy of photon. Clear? E is the energy of photon, and it is equal to h nu. Nu is nothing but the frequency of what? Radiation. Radiation in a frequency equal to what? Energy of the photon, right? Higher the energy, higher will be the what? Moment of electron. Since striking photon has energy equal to h nu, the minimum energy is required to eject electron is h nu naught. Once again, also called as what? Work function. So W naught. So then the difference in energy h nu to h nu naught is transferred as a kinetic energy of the photo electrons. So whatever the ejected electrons, we are calling photo electrons, right? So avaga mu requires mu naught energy, threshold frequency. But now we are dealing with what? Photoelectric effect, that is through the Einstein. So he is telling that h nu naught, energy is equal to h nu naught. Okay. So h nu is equal to h nu naught plus half m e v square, where m is the mass of the electrons, right? Mass of the electron, and v is the velocity associated with the ejected electrons. So by that you can say that is h nu is nothing but energy. So E is equal to h nu naught plus half m v square, right? H nu naught, this, that is the minimum energy is required for the photoelectric effect. And after a photoelectric effect, the ejected electrons come out and it will move, and that is through the kinetic energy. And that kinetic energy we are calling half MeV square, right? That kinetic energy plus what, work function, so that is h nu naught, together form what, h nu. So that frequency, or else that